Okay, so we're going to try another set of problems that is actually going to be chain rule based, kind of a combination of looking at some tables, some actual chain rule, combining some data off of graphs. This is a pretty challenging question. It's actually the number 6 problem off of the 2017, which is a very, very recent exam. Usually the 6th problem is the one with one of the lowest scores because people tend to be a little bit fatigued at that time. They also tend to ask some pretty aggressive questions at that time. So you're going to see that in this particular problem, it is pretty challenging, but we're going to hopefully do a good job, and hopefully we'll be able to see things pretty well. So here we go on the 2017 problem 6. So notice that right up here they give us a table that talks about G and G prime, and this is H, so there doesn't really appear to be any connection between these two values. And then so we've got a data table, we got a little graph, and then all of a sudden there's like this equation down here. And so notice we've got a G, we've got an H, we've got an F. All this stuff is going on, and it says G, which they didn't really tell us much about it other than this data, but they say it's a differentiable function, which also, of course, tells you it's continuous. And the table tells you that it's a G prime. Okay, that just tells us it gave us the stuff. So H is a function that has all these little line segments. And so it says, let's find the slope of the tangent of the line of F. So out of these 3 values, they're focusing us in on F. And so if we want the slope of the tangent line, there we want to find, first off, what is f prime of x, and therefore once we have f prime of x, let's find f prime of pi. Now, keeping in mind that this is not a calculator allowed question, we're going to actually have to find f prime, and in fact they do go ahead and give points for that. So f prime of x, so let's see, the derivative of the cosine was the negative sine. And then chain rule says we have to multiply by the derivative of what's inside, which of course is 2. And then of course we know that the derivative of e to the u is e to the u du. So this is e to the sine x. And of course the derivative of the sine is the cosine. So if I want to find f prime of pi, I need to take negative 2 sine of 2 pi plus e sine pi times the cosine of pi. Now over here I'm just going to draw a little picture. Here's where 2 pi is, here's where pi is. This is the coordinate 1, 0 and negative 1, 0. Kind of an old school unit circle problem that we haven't done in a while, but you want to remember that the cosine was always the x value and the sine was always the y value. So if they're asking for the sine of 2 pi, that value would be 0. If they're asking me for the sine of pi, that number again would be 0. And the cosine of pi would be right here, and that would be the number negative 1. So it looks like we have a 0. Remember, e to the 0 is the number 1. And so that entire value appears to simply be negative 1. That's our first problem. Now, moving on to this one. Now, k is a new function. So now we have f, g, h, and k. My goodness, lots of functions. So if we want to find k prime of pi, we need k prime of x first. So k prime of x, this is a straight chain rule problem. It is the derivative of the outside function times the derivative of the inside function. So I want to find k prime of pi, which is h prime of f of pi times f prime of pi. Now, the nice thing is we actually did find f prime of pi above, and you will notice that on the AP test, if you do make a mistake, they do grade with you. So if you made an error here and your answer was consistent with this, as long as there was a valid effort given, they won't dock you further. They'll go ahead and read with you on these problems, believe it or not. But you know what? We haven't found f of pi yet. That's kind of interesting because I need that right here. So f of pi, going to the original problem right there, would be the cosine of 2 pi plus e to the sine of pi. And the sine of pi was the y value, which is 0. And we already figured out that that's a 1. And the cosine of 2 pi is, well, the cosine of 2 pi right here is 1. So it looks like f of pi is the number 2. So we're looking at h prime of 2 times f prime of pi. And f prime of pi we found right here to be the number -1. And h prime of 2, oh, now they're actually bringing us to the graph. So they're asking, what is the slope of h? What is the slope of h at the number 2? Now, they did tell us that this is a piecewise linear function. So if I went over 1, 2, 3, and down 1, this graph is dropping 1 and running 3. So this entire thing has a slope of -1/3. And that gives us a cumulative answer of 1/3. You can see there's a lot of work being done in that problem. That's a pretty tricky little question. And so when we go on to part C, they kind of don't let off the gas. They're going to make us do something, again, that's honestly fairly challenging. So this time they're going to ask us to do a chain rule and a product rule together. So keep in mind, when we do a product rule, we do the derivative of the first times the second plus the derivative of the second times the first. So if I want to know what m prime of x is, I need to take the derivative of this, which would be g prime of -2x, but chain rule says I have to multiply that by -2. So this is all the derivative of the first times the second, plus the derivative of the second times the first. And now I want to know what happens if I evaluate this m prime that I found right here at the number 2. So I still have my -2 from there. This is now going to be g prime of -4, h of 2 plus h prime of 2 times g of -4. Now, that's just a lot of information going on. Where is all this stuff coming from? So keep in mind that g was taken from this. So when we want to know what is g prime of -4, g prime of -4 was right there. It's -1. H of 2, no, well, h was the graph. So I want to know what is h of 2. Keep in mind this graph was dropping at a rate of 1/3. So if I move over 2, it is at the value -2/3 plus h prime of 2. Well, again, what is h prime is the slope of h at the number 2, which we already found to be -1/3. And finally, what is g of -4? Well, g of -4 right here is the number 5. Well, we don't get to use a calculator, so we do have to do a little bit of tough stuff here, but these aren't too bad because 2 times 1 times 2 is 4/3, and I see 1, 2, 3 negatives. And over here, we have a -5/3, so -4/3 and -5/3 is -9/3, or a total of -3. And now we're finally on to the last portion of this beast, and that is there some value where the slope has to be -4? Well, they kind of are giving you a little bit of a hint, and they're saying, is there somewhere where this thing has to have a slope of -4? And they're referring to g, and we don't know much about g other than the fact that it is a differentiable function. And so they're asking us to look back from -5 to -3 right here. And so what I'm going to do is I'm going to go ahead and I'm going to say, well, what is the slope on here? And so if we look at y2 minus y1 over x2 minus x1, and I grab those numbers directly off of the chart, g of -3 was 2, g of -5 was 10, and of course this difference is 2. Lo and behold, we end up with this value, which is -4. And so since this is a differentiable function that has an average rate of change of -4, then there is a guarantee by the mean value theorem See, if you have two graphs, it doesn't matter how it goes, whatever this slope is, somewhere the slope as you move along this curve will have that exact same slope. So by the mean value theorem, there is at least 1C, and I'll go ahead and define that so it's very, very clear that I'm saying that it's in this interval where G prime of C has to be -4. Certainly not an easy question in places, but definitely doable. It does actually follow exactly how we've studied the calculus over this year. So we're going to go ahead and take a look at another one of those in a moment. All right. Have a good one.